Hello and welcome back. We've got another video. What are we doing today? We are differentiating each of the following with respect to x. We've got a combination of chain rule. That's A and B. C and D look like quotient rule. And E is a product rule. Maybe we'll just pick one of each type here and see how that goes. So A, 2 minus 5 root x in brackets squared. So if I just say y equals that thing, y equals that, let me just use the chain rule to solve this. So I can see I've got a function of x inside some brackets and it's being squared. So that squared makes it a function of a function. So y equals u squared, where u is 2 minus 5 root x. Now I could write root x, but root x is also the same as x to the power of a half, and having a power there just makes it a little bit easier to derive. Now let's derive each part separately. So dy du equals to u, not u2. And let's look at u now. So du dx will equal to 2. That's a constant. It's gone. We've got a negative 5. This power will come out the front, so times a half. Take one off the power, that'll turn to x to the power of negative a half. Now the reason we did all this is because of the chain rule. So dy dx equals dy du times du dx. So dy du is 2u, du dx is all of that. So that's going to be negative 5 on 2 x to the power of negative a half. Index laws allows us to put that on the bottom of the fraction with positive powers. Now the u, that's obviously this term here. So let's write it in terms of the original form. 2 times negative 5. Oh, hold on a second. I could cancel out. Let's do that. That 2 and that 2. Bam. They're gone. They're out of here. So we'll have negative 5, open bracket 2 minus 5 root x all over root x. Now, this question, is it fully answered? Depending on your textbook, you may need to rationalize the denominator, or depending on your teacher. So let's go a little bit further. So to rationalize the denominator, we've got a square root of x. Some people don't like that. So if we multiply the top and bottom by a square root of x, that will allow us to just have x on the bottom, like so. Don't forget this bracket here. We could expand the brackets, maybe it'll simplify a little bit more. We'll have negative 10 root x plus 25x all over x. Now we could split this fraction up into two separate fractions, but keeping it as a single fraction as opposed to two separate fractions is probably preferred. And that can be our final answer. If you stopped here, I don't think that would really be a problem, but again, it depends. I would check what answer is preferred. The top bit being factorized is quite nice, but again, it depends. So this was a chain rule example. Let's look at a quotient rule. Now both of these have got a square root of x. That's fantastic. Let's try D. We've got x squared plus 2 all over root x. So this we can recognize as a quotient rule. We've got a function of x over a function of x. Well, u is just x squared plus 2. Du dx is 2x. Very nice. What is v? V is the square root of x, but we know that that is the same as x to the power of a half. Dv dx is going to be 1 over 2 root x. We can just have a look over here. We remember that we had x to the power of a half. When we derive that, it becomes 1 half x to the negative a half. That negative a half power means that we can put it on the bottom of the fraction and make the power positive. And this is quite a common problem. So if you feel comfortable, please feel free to do that in one step. But if you're not sure, I would continue with this step here, where you break it down a little bit further. Now, let's get back to d. So dy dx, which is what we're trying to do, we're trying to derive this equation, is equal to v du dx minus u dv dx all over v squared. What a great looking quotient rule. Oh, beautiful. Now let's sub some stuff and we got v. That is the square root of x. Du dx, that is 2x. We've got a minus u. U is x squared plus 2. Dv dx, that's this beast over here, 1 over 2 root x, and that is all over, hold up, let me put brackets around everything I'm subbing in. That is all over v squared. V is already x to the power of half, squaring that makes it x. That's very nice. Alrighty. Oh, we've got a fraction on top of a fraction. That's no good. That's very messy, but let's keep going. Let's see what we get. We'll have 2x root x minus x squared plus 2 over 2 root x all over x. Wow. If you want to just pause the video, just close it right now. Feel free. But this is no, don't close it. Please stay. This is quite the fraction. All right. Well, how do we break this down? Well, let's just work through it. So we've got this thing here. This is the problem, really. That's the real problem. If we can make maybe both terms with a 2 root x on the bottom, I think that'd work quite nicely. So 2x root x times 2 root x over 2 root x minus x squared plus 2 over 2 root x. That will allow us to combine our first two terms here and combine them into a single fraction. And this is all over x. And what I'm going to do is put that in brackets and say divide by x. That'll just make things a little bit easier down the road. So let's now combine this term here. We'll have 4x squared over 2 root x minus x squared plus 2 over 2 root x divided by x. Now, instead of writing divided by x, what I'm going to do is I'm going to multiply by its reciprocal. I'm going to multiply by 1 on x. And you can see, oh, that makes it a little bit easier. We've now kind of gotten rid of the fraction on a fraction. We're now multiplying by this 1 on x term. Makes it a little bit easier. So let's combine these fractions here. We've got 4x squared minus x squared plus 2. And I'm going to keep that in brackets. Big problem here. You're minusing this entire fraction. So that needs to be in brackets. All over 2. And if you multiply by x, we'll have 2x root x. Let's go a little bit further. Let's expand those brackets and keep solving it. Oh, don't forget those equal signs. We'll have 3x squared minus 2 all over 2x root x. Oh, we got a root x on the bottom. We've got to rationalize that. I don't like it. So multiply top and bottom by root x, we'll get root x 3x squared minus 2 all over 2x squared. Root x times root x is just another x, so 2x times x, 2x squared. And that, the top is factorized nicely, the bottom does not have a square root of x. That is done for question D. Now I did say I would like to do one of each, so I will. I'm going to do something pretty tricky here. Ooh, I moved down. But hold on. I need to remember what e is. E is 3 root x in brackets x squared plus 2. Let's see if I've remembered that. 3 root x in brackets x squared plus 2. Let's just double check we've written that down correctly. 3 root x, x squared plus 2. Yes, fantastic. Alrighty, I'll just continue that here. This is, of course, a product rule. We've got a function of x multiplied by a function of x. In this case, u equals 3 root x. V equals x squared plus 2. We've got du dx, which is going to be, we got that root x again. So we know that's going to be 3 times 1 on 2 root x on the bottom there. We've got this very common x to the power of a half, 1 on 2 root x. If you've got any other root, maybe a cube root or a fourth root, I would definitely go through that process fully. But if you're feeling confident with square roots, please feel free to do this. Div dx now. Oh, this is beautiful. Whoa, hold on. That is not an equal sign. Oh, that's much better. Whew. Alrighty, we've got the product rule. We've got a function of x times a function of x. That will be dy dx equals v du dx plus u times dv dx. Now you might have seen it as u div dx plus v du dx, but I always like to write the v first because the v comes first in the quotient rule. So I just like to be consistent and just help myself remember the correct process, the correct order that the terms need to be in. So I can sub all of this in. V is x squared plus 2 du dx. Ooh, this is our fun fraction. 3 over 2 root x plus, what's u? U is 3 root x. Div dx is 2x. Now let's expand this. We've got x squared plus 2 in brackets 3 all over 2 root x plus 6x root x. We've got two separate terms. We can gather them up by multiplying this right-hand term by 2 root x, 2 root x. So that is the same as multiplying by 1. So we'll get 3 over bracket 3, x squared plus 2 over 2 root x plus 12x squared over 2 root x. We can now combine these terms and we can in fact simplify a little bit. So we'll have 3x squared plus 6 plus 12x squared all over 2 root x. Let's gather up some like terms. We'll have 15x squared plus 6 all over 2 root x. We've got a root x on the bottom again. Gosh darn it. Let's rationalize that denominator. That just means getting rid of the square root. So we'll have square root of x. 15 and 6, we've got a common factor. Let's factorize that. We'll take a 3 out as well. What's left over on the inside? We will have 5x squared plus 2 all over 2x. There we go, and that is our fully rationalized answer to question E, which was, where is it? 3 root x, open bracket, x squared plus 2. So I'll just leave it here for a little bit. Pause the video if you need to check anything. And I'll just go back up to the top. And here is the questions in all their glory. Alrighty, thanks for joining me. That's all the time we've got for today, and I'll see you next time.